We have looked at relations, and today we're going to look at functions, and functions are just special relations. A function is a relation, which you'll remember is just a set of ordered pairs, where each x value is paired with only one y value. Each x value is paired with only one y value. So, from the Reader's Theater, we talked about this. If the x values repeat, it is not a function. Now, that's not going to be a good enough explanation. We'll talk about that in a minute. But basically, this is what you're looking for. Do you have any x values that repeat? If so, it's not a function. So we're going to look at the types of the different representations of functions that we looked at the other day and determine whether they are functions and explain. Okay, so I have a set of ordered pairs here. 5, -2, 3, 5, 2, -5, 0, -2, -1, 3. And I want to know, is this a function? So what I'm looking for is each x value paired with only one y value. So I look through here, do any of my x values repeat? 5 is only paired with -2, 3 is only with -5, 2 is only with -5, 0 is only with -2, -1 is 3. So this is a function. Because each x value is paired with only one y value. It meets the definition of a function. Notice we don't care about the y values. This y value shows up twice, but we don't care. Y's don't matter when we're trying to decide if it's a function. We only look at the x values. Okay? Look at this next set of points. Is this a function? Look at your x values. Is there any x value that is paired with more than one y value? 2 is, right? 2 is paired with -4, and 2 is paired with 4. So this is not a function because an x value, specifically 2, is paired with more than one y value. In this case, it was -4 and 4. All right, let's look at a table. Are these tables functions? Do these tables represent functions? We want to look at our x values. Does every x value only have one y value? Well, every x value only shows up one time, right? So this is a function because each x value is paired with only one y value. Remember, we don't care about the y values. I see a y value that repeats. I don't care. All I care about is the x values. Now, look at the second table. Is this a function? Does every x value have only one y value? Well, I see that -1 shows up twice. Okay, so since one of my x values repeat, this is not a function. Because one x value, in this case -1, has two y values, 2 and 3. Okay? Now, mapping diagrams. Mapping diagrams are a little different. We have to follow our arrows. Does negative 3 only go with one value? Does negative 2 only go with one value? 5 is only paired with one value. 1 is only paired with one value. So this is a function. Each x value has one y value. That's our reason, and that's what we need to write. Okay? Now, look at the second mapping diagram. What do you think? Look at your arrows. Is there an x value that has more than one y value? Do you see it? Circle it. What do we say about this mapping? This is not a function because an x value, in this case negative 1, has two y values. What are the two y values? 4 and 5. Now, the last thing we want to look at is how to tell from a graph. And the way you tell from the graph is you use the vertical line test. The vertical line test says if a vertical line intersects a graph more than once, it is not a function. What does a vertical line look like? The vertical line is up and down, right? So you're going to put a vertical line up and down through the graph. If it intersects the graph more than once, it fails the vertical line test. So here we got a bunch of points. Well, if I put a vertical line here, it only intersects in one place. Here, one place. Here, I intersect twice, right? If I put a vertical line through there, I intersect there and there. So this is not a function. Now, it failed the vertical line test, but what does the vertical line test have to do with the definition of a function? Well, the deal is this x value right here has two y values, right? This x value on the x-axis has this y value and this y value. So it fails the function test, the vertical line test and the function test because an x value has more than one y value. Okay, now look at the next set of dots. Put a vertical line there, it intersects once. There, it intersects once. There, once. There, once. I'm good. This one is a function. It passes the vertical line test, but that's not the reason we want to use. We want to say each x value has only one y value. Okay, so those were relations that were just plotted points. Now let's look at actual graphs. Here I have, this is a parabola. You'll learn about it in Algebra 1. If I put a vertical line anywhere through this function, it only intersects the graph one time. Okay, so this one is a function. It passes the vertical line test, but the reason we want to write is each x value has one y value. Okay? What about this circle over here? Is it a function? If I draw a vertical line anywhere through the graph, will it intersect it more than once? Lots of places, right? How many places does it have to fail the vertical line test? Only one. Once we find a vertical line that intersects the graph twice, it fails. This x value has two y values. So this is not a function. Because there is an x value. There's actually lots of x values, right? An x value has more than one y value.